Let us continue our discussion on energy scenario. After coal, the important energy resource is crude oil. Petroleum dominates the world economy. No other commodity affects everyday life the way petroleum does. We cannot move a kilometer without the use of petrol or diesel. So that is a dependence of the diesel and petrol. So we obtain these from crude oil. What are the petroleum products? LPG, motor spirit, naphtha, aviation turbine fuel, superior kerosene oil, high-speed diesel, light diesel oil, various types of lubricants and greases, then furnace oil, which is used in industries for process heating, then low sulfur heavy stock oil, which is a bit viscous, used as an alternative to furnace oil in industries, then bitumen, which is used in road building, and others. So these products are very useful to us in our day-to-day life. That is, all these products are the extracts of crude oil. Such is the importance of crude oil. So how crude oil is formed? Petroleum, we can say. How petroleum is formed? So 300 or 400 million years ago, at the bed of the ocean, tiny sea plants and animals died and were buried on the ocean floor. Over time, they were covered by layers of silt and sand. Then 50 to 100 million years ago, this sand and silt exerted pressure on these plant and animal remains. So they were buried deeper and deeper. The enormous heat and pressure turned them into oil and gas. So today we drill down through the layers of sand, silt and rock to reach the rock formations that contain oil and gas deposits. That's how we obtain crude oil and natural gas. Petroleum dominates the world economy. The crude oil is found in reservoirs, in sedimentary rocks. Tiny pores in the rocks allowed the oil to seep in. These reservoir rocks hold the oil like a sponge confined by other non-porous layers that form a trap. So traps are basically crude oil reservoirs from which oil is mined. Oil reserves at the world level. So at the world level, the oil reserves amount to 239.3 billion tons. The R by P ratio, reserves to production ratio of oil, of course at 2018 level is 50.2 years. So you can see crude oil is going to last another 50 years or another 51 years. As far as Indian scenario is concerned, we have a meager reserve of oil, which is 0.6 billion tons, 0.3% of the world reserves. So India has 0.3% of the world reserves. Our R by P ratio is 14.4 years. So another 15 years we will not be producing any oil. Now, as far as producers, exporters and importers of oil at the world level are concerned, Saudi is the largest producer of oil. Saudi nearly holds 35% of the world oil reserves, followed by Russian Federation. Recently, Venezuela has also tapped very large resources of oil. So Venezuela recently has moved up in this line to maybe second or third position. So currently Saudi Arabia is the largest producer of oil, having largest reserves, followed by Russian Federation and then by United States. Next exporters of oil Among net exporters of oil is again Saudi Arabia. Saudi is exporting a lot of oil. Russia is also exporting a lot of oil. Nigeria is exporting oil. Net importers. Net importers are United States is the top importer, followed by China, and we are world's third largest importer of crude. So due to the heavy dependence of crude, we have to import the crude and crude. You can see here what quantity of crude we have imported. Of course, these are 2013 figures of the International Energy Agency. So a lot of crude India is importing. As regards management of oil export import, the Organization of Petroleum Exporting Countries, OPEC, is very famous. OPEC was founded in Baghdad, Iraq, in September 1960. This OPEC is formed by oil producing countries from Middle East. The objective behind formation of OPEC was to unify and coordinate members' petroleum policies. Then members of OPEC hold 72.6% of oil reserves in the world. They literally control the oil reserves production of oil in the world. Since 1982, OPEC also sets crude oil production quotas of its member countries. So a member country cannot go on indiscreetly producing the crude oil unless it takes permission from OPEC. Crude oil is traded in barrels, and the physical and chemical properties of crude differ from field to field, and depending on the chemical and physical properties, the price of the crude oil is determined. So categorization of crude oil on the basis of the physical characteristic is called crude oil benchmarking. So pricing is done on the basis of crude oil benchmarking. Benchmarking of crude oils depends mainly on their density. Lighter, a crude can be lighter or denser, and sulfur content. So a crude oil is sweet if it has less than 0.5% of sulfur content. It becomes sour when the sulfur content crosses 0.5%. Crude oil price benchmarks were first introduced in mid-1980s. There are three official benchmarks: Western Texas Intermediate, that is WTI, Brent Blend, and then Dubai Crude. Recently, two other benchmarking are used for trading and pricing purposes. Those are New York Mercantile Exchange and OPEC Basket. The basis of crude oil pricing is the API gravity. API is American Petroleum Institute. So the API is an inverse measure of the relative density of crude oil. The density of crude oil determines its price. So API is the inverse measure of the relative density of crude oil and is expressed in degrees. The scale is designed such that most values would fall between 10 to 70 degree API. So if API is greater than 10, it means the liquid will be lighter than water. API less than 10 means the liquid is heavier than water. So the API of petrol varies from 25 to maybe 50. API gravity is given with this formula: 141.5, which is a constant, divided by specific gravity of the crude minus 131.5. So if specific gravity of crude is say 0.8, then 141.5 by 0.8 approximately comes out to be 170, and then the API gravity comes out to be 32, 35. So 40, the higher the API gravity, the better is the oil, the better priced is the oil. In crude oil industry, production quantities of crude are measured in metric tons, but they are traded, crude is traded in barrels. So it is important to know barrels of crude per ton. 1 barrel of crude oil contains 159 liters, which is 5.34 gigajoules, which is, as we remember, 1 gigajoule is 10 raised to 9 joules. So in gigajoules, 1 barrel of crude oil has 0.1272 tons of oil equivalent, and 1 ton of oil equivalent is 42 gigajoules. So 1 ton of oil equivalent corresponds to 7.86 barrels. Now, availability of crude in India. Now, these are proven commercial productivity sources. Actually, these are in estimate form. So, in this area, like in some part of Gujarat, some part of Maharashtra, coastal area of Maharashtra, Gujarat, and Rajasthan, some oil is available, possibility of oil available, and explorations are going on at the private level. Here, Digboi in Assam and all, in this region, some oil is available. Here in Godavari Basin. So, Godavari Basin, some oil explorations are going on, some proven research reserves are found, but still explorations are going on. No gross resources have been found, and no mining is being done. What is the crude oil scenario in India? So this table speaks about the production in million metric tons, production of petroproducts, consumption of petroproducts, refining capacity per annum, crude import in million metric tons, and in bracket the quantities are mentioned in billion barrels, and the prices in US dollar per barrel, and in Indian rupee exchange rate at that time is mentioned here. Now in 2015-16, our production was 36.9 MMT, but production our crude production was 36.9, but production of petroproducts was 231.9. So our petroproducts production was higher than our crude production. How this is possible? Because we have imported the crude. So the crude import was 202.8, that we processed. So the crude import was 202.8 million metric ton. In the next year, again, the production is 36, production 243, import 213.9. So one thing can be inferred from this table is that though our production of crude oil is less, our refining capacities are more. We have great refining capacities, and that becomes our strong point in India. Like Reliance or Mangalore refineries. These refineries have a great refining capacity, so that becomes a good foreign currency earner for India. So that is a plus point in Indian technology. Now, as regards what cost we are paying to import the crude oil, let us concentrate on 2017-18 figures. So the production of crude oil was 37.3 million tons, and the petroproducts production was 243.5, consumption 201, then crude imports were 217.0, and at that time the price of crude oil was 53.59 US dollars per barrel. Now we have spent nearly 115.94 lakh crores of rupees in 2017 and 18 for importing the oil. So you can imagine what a huge amount we are spending on import of crude oil. So this is really a matter of concern for us Indians to look out for the alternative. This scenario is presented for making you aware of this situation. In upstream sector, now the organizations which are related to production and exploration of crude oil are In the upstream sector means the industries which explore and extract the oil. They bring the oil to the ground level. And downstream sector are those which refine. They take the oil from the exploring companies and they refine them. So those are downstream sectors. So in the upstream sector, the two upstream national oil companies, that is Oil and Natural Gas Corporation ONGC and Oil India Limited OIL, play a dominant role with a total share of about 68% in oil and gas production in India. Presently, ONGC produces nearly 58.9% of indigenous crude oil and 65.8% of country's gas production, while Oil India Limited share is 9.2% of indigenous crude oil and 7.4% of gas production. So the share of private and joint venture companies in oil and gas production is 32% and 26% respectively. New exploration licensing policy has enabled the private companies to explore and refine crude oil. So this is the situation about crude oil. Let us turn our attention to natural gas and spend some minutes on the gas. Natural gas is a hydrocarbon gas mixture consisting primarily of methane. Natural gas is an energy source often used for heating, cooking, and electricity generation. It is also used as fuel for vehicles and as a chemical feedstock in the manufacture of plastics and other commercially important organic chemicals. Before natural gas can be used as a fuel, it must be processed to remove impurities, including water, to meet the specifications of marketable natural gas. So the marketable natural gas must be clean. The byproducts of this processing include ethane, propane, butane, pentane, and higher molecular weight hydrocarbons like hydrogen sulfide, carbon dioxide, water vapor, and sometimes helium and nitrogen. Natural gas is often informally referred to simply as gas, especially when compared to other sources such as oil or coal. Natural gas is a major source of electricity generation through the use of cogeneration, gas turbines, and steam turbines. It is also well suited, the energy source, natural gas is also well suited for a combined use in association with renewable energy such as wind and solar. Most grid peaking power plants, grid peaking means when the demand of electricity is very high, particularly in evenings or particularly in mornings. So that is called grid peaking. Most grid peaking power plants and some off-grid engine generators, they use natural gas. Natural gas power plants are very popular as grid peaking power plants. They shave the peak of the demand. Particularly high efficiencies can be achieved through combining gas turbines with steam turbine in combined cycle mode. Combined cycle mode is very popular mode of operation. Natural gas burns more cleanly than other hydrocarbon fuels such as oil and coal and produces less carbon dioxide per unit of energy released. Combined cycle power generation using natural gas is currently the cleanest available source of power using hydrocarbon fuels. And this technology is widely and increasingly used as natural gas can be obtained at increasingly reasonable costs. Quantities of natural gas are measured in normal cubic meters corresponding to 0 degrees Celsius at 101.325 kPa. The gross heat of combustion of 1 meter cube of commercial quality natural gas is around 39 megajoules, but this can vary by several percent. So this comes to about 49 megajoules for 1 kg of natural gas, assuming the density of natural gas to be 0.8 kg per meter cube. So this is an approximate value, of course. In European Union, gas is sold in the units of BTU, British thermal units. In the United States, retail sales are often in units of therms, that is TH. So 1 therm is equal to 1 lakh BTU. So gas meters measure the volume of gas used, and this is converted to therms by multiplying the volume by the energy content of the gas used during that period, which varies slightly over time. Natural gas reserve scenario. So world has 193.5 trillion cubic meters of gas with R/P ratio, reserves to production ratio, 52.6 years, and India has 1.2 trillion cubic meter of gas reserves, which amounts to just 0.6% of the world value. So again, we don't have a lot of gas with us. Our R/P ratio, reserves to production ratio, is 43.6 years. United States has the highest natural gas reserves, followed by Russia and Qatar. Qatar has higher larger gas resources, followed by Iran, Canada. Exporters, Russian Federation is the major exporter of gas, followed by Qatar and Norway. Net importers are again Japan, Germany, Italy, and Korea. At the Indian level, natural gas production imports, we have in 2016-17, we have produced 31.9 billion cubic meter of gas, and in 2017-18 it was 35.2. There was some increase, 1.1 or 1.2% of increase in production. So in 2017-18, out of 35.2, 19.65 billion cubic meter of natural gas was imported, out of which Qatar has supplied the major quantity, that is 10.1 billion cubic meter. Just for the sake of understanding, gas price in 2019 was $2.34 per million British thermal units. Let us briefly talk about the nuclear energy source. Nuclear energy is the use of exothermic nuclear processes to generate useful heat and electricity. The term includes nuclear fission, nuclear decay, and nuclear fusion. Presently, the nuclear fission of elements in the actinide series of the periodic table produces the vast majority of nuclear energy in the direct service of humankind. The actinide series encompasses the 15 metallic chemical elements with atomic numbers from 89 to 103. Nuclear fission power stations provided about 5.7% of the world's energy and 13% of the world's electricity in 2012. So in 2013, the International Atomic Energy Agency reports that there are 437 operational nuclear power reactors in 31 countries. There is an ongoing debate about nuclear power. Proponents, like those who are for, those who want the nuclear power, proponents such as the World Nuclear Association, the IAEA, and environmentalists for nuclear energy contend that nuclear power is safe, sustainable energy source, so nuclear energy is a sustainable energy source that reduces carbon emissions. Opponents such as Greenpeace International and Nuclear Information and Resource Service contend that nuclear power poses many threats to people and the environment. So the economic cost of nuclear power accidents are high and meltdowns can take decades to clean up. The human cost of evacuations of affected populations and lost livelihoods are also significant. Along with other sustainable energy sources, nuclear power is a low carbon power generation method of producing electricity. Japan's 2011 Fukushima Daiichi nuclear disaster, which occurred in a reactor design from the 1960s, prompted a re-examination of nuclear safety and nuclear energy policy in many countries. Germany decided to close all its reactors by 2022, and Italy has banned nuclear power. Following Fukushima in 2011, the International Energy Agency halved its estimate of additional nuclear generating capacity to be built by 2035. The current scenario of nuclear energy is, at the world level, the installed capacity is 596.4 million tons of oil equivalent, while India has 1.4%, that is 8.5 million tons of oil equivalent. Hydroelectricity. Hydroelectricity is the term referring to electricity generated by hydropower, the production of electrical power through the use of gravitational force of falling or flowing water. It is the most widely used form of renewable energy, accounting for 16% of global electricity. This is 2010 figure, and it is expected to increase about 3.1% each year for next 25 years. So the cost of hydroelectricity is relatively low, making it competitive source of renewable electricity. The average cost of electricity from a hydro plant larger than 10 megawatt is 2 to 3 rupees per unit. It is also a flexible source of electricity since the amount produced by the plant can be changed up or down very quickly to adapt the changing energy demands. At the world level, China is the largest hydroelectricity producer. Brazil and Russia are other major generators of hydroelectricity. At the world level, the potential of the installed capacity of hydroelectricity is 918.6 million ton of oil equivalent. It is equivalent to oil. At the Indian level, we have 3.3% contribution in hydroelectricity. As regards renewable energy, we will not talk much in this presentation because we are going to give a detailed review of renewable energy in the coming presentations. Just for the sake of mentioning, renewable energy at the world level, the installed capacity is 486.8 million tons of oil equivalent, and the Indian contribution has been 21.8 million tons of oil equivalent, 4.5%. So this is a 2018 figure, but the contribution of India in renewable energy is increasing fast. A quick review of biofuels. Biofuels are derived from biomass. They are biomass resources. So they are obtained from vegetable oils, both edible and non-edible. So biodiesel substitutes for diesel. The most common blend in India is B20, which is a mix of 20% biodiesel and 80% mineral diesel. Currently, this biodiesel is obtained from certain plants called jatropha. So small quantities of jatropha and other non-edible oilseeds procured by traders are mostly crushed for oil and then which is used. Previously they were used in lighting lamps, but now they are used for mixing in the diesel, regular diesel in B20 blend. So the cost of biodiesel is much above the government advised purchase price of 26.5 per liter. So the program of B20 biodiesel has not been considered to be a successful program. Another fuel which is coming is ethanol. Ethanol is regarded as alternative to petrol, alternative to gasoline. So the blending of 10% of ethanol, E10, has been proven. The problem with ethanol is that it contains more oxygen, 35% oxygen. So the temperatures of combustion are higher and NOx formation is a problem with ethanol burning. Government has encouraged ethanol production and ethanol entry into the transportation fuel. Government has fixed the administered price of ethanol during ethanol supply period from 1st December 2017 at rupees 40.85. It's a very good price offered by the government per liter of ethanol. So in spite of this good offer, the ethanol program is not taking up because the supply of ethanol to petroleum industry, it was affected by the short supply of molasses. Molasses is a raw material from which ethanol is formed. So the manufacturing companies are short of molasses and continued strong demand for ethanol from other competing industries. Most of the ethanol suppliers prefer to supply to chemical and liquor industries due to high realized prices. So these are the reasons why ethanol program is not picking up. With this, we come to the end of energy scenario 2. The next session will be overall energy scenario and energy security concerns before India. Thank you very much. Your comments are always welcome on this presentation.